All right, this is your tutorial for Big Ideas Algebra 2, Section 3.1, Solving Quadratic Equations. So what we're going to do with this specific section is break it up into two different parts. The entire 3.1 goes over multiple different ways to solve quadratic equations, but I want to just focus on only graphing for this tutorial. So I'm going to call it 3.1a, and we're only going to talk about solving quadratic equations by graphing. So continuing back to how we were graphing quadratic equations previously, in order to solve a quadratic equation is another way to say you're finding the root of the equation, which in a quadratic graph is the same thing as saying, where does this quadratic equation cross the x-axis? Remember, all quadratics were parabolas. They could be written in standard form, which is your ax squared plus bx plus c. And in that U-shaped, whether it was pointing up or down, it would at some point cross the x-axis twice, because it goes on one side and then could come back down, or it goes back up depending on whether it's pointing up or down. But basically for graphing, you're just finding where the quadratic equation crosses the x-axis, and what those x values are your solutions to the quadratic equation. So when you have these two quadratics, looking at the first one, x squared minus x minus 6 equals 0. Remember, in order to solve, they have to be equals. So if it's not equal to 0, the first thing you need to do is make sure that it does equal 0. Put everything over on one side in standard form and set it equal to 0. So when you draw that graph, that parabola looks like this. So it is a positive a, which means it's going to point up. You could graph this by hand, use your negative b over 2a to find your axis of symmetry, and then plug it back in to get your vertex. I believe this axis is 1/2 or 0.5, and then your vertex, when you plug that back in, is something like a negative 5.25 or something similar to that. But you could use a graphing calculator using your Desmos website or something to get that graph to look like this. And basically all you're doing is identifying where the x-intercepts are. So notice that that graph crosses the x-axis over here on the left side and on the right side. So the point -2, 0 is an x-intercept, and the point 3, 0 is your x-intercept. You don't need to put the entire coordinate. All you need to do is just put the x values of where that graph crosses, and those are solutions to your quadratic equation. Again, I may say the word roots a couple times. You may hear some other instructors say the word roots or zeros. So solutions, roots, zeros all mean the same thing. When you check that in and you're solving for the 0, it's called the 0 because it equals 0. You could just plug that back in and see if you get it equal to 0 when you're simplifying down. So the first one you could check is -2 squared. You get 4. Double negative is +2 minus 6. It does equal 0. You also could check that over with your 3. So plug the 3 into both sides. You would get 9 minus 3 minus 6, and it does equal 0. So could be a good way to check algebraically, just in case if you're typing something into the graph wrong or formatting a missed sign somewhere along there. All right, so remember when I said that it has to be equal to 0? For part B, the first thing you should notice is that there is no 0, so you need to move this +4 over to the left-hand side, and that is by subtracting your 4x. And please put them in standard form. It's going to make it a lot easier just for the rest of this chapter if you're including everything in standard form. So your new equation is -2x squared minus 4x minus 2 equals to 0. Plug that into your graphing calculator. And notice that it points down because your a is a -2. So when you graph that function, it looks like that. You could do your negative b over 2a to get your vertex of, looks like -1, or your axis at -1, and then you plug that back in to get your vertex, and that's the coordinate point. But notice that this graph, it only crosses at one point. So your vertex is actually your x-intercept. So there's only one solution. Sometimes there will be 2, sometimes there will be none, sometimes your answer will be no solutions. Sometimes your graph will never cross the x-intercept, but it will never be more than 2. So in this part B, it's just one solution, which is -1. And then you could always plug that back into your equation and check to see if that is actually equal to 0 from there. So a couple possible solutions. You could get it crossing twice here. You could get it crossing once. Or if this graph was even shifted down and your vertex was down here, it would never cross the x-axis. But again, you're never going to have more than 2 solutions to quadratic equations.